All through the range of science, individuals have tried to understand how the universe started. The most comprehensively seen clarification has been something many suggest as the speculation of how things became. Various appraisals and crafted by incredible numerous experts support this idea, giving confirmation about how the universe began. Regardless, in the ongoing universe of science, new innovation brings us novel contemplations and viewpoints. These thoughts challenge our previous assumptions. Neil deGrasse Tyson has turned into a tremendous figure in this creating universe of science. Presently, something energizing is happening with the James Webb Space Telescope, something that could make us question the speculation of the enormous detonation. The James Webb Space Telescope has tracked down 750 new worlds. These universes are not what we expected, driving us to rethink what we assumed we had some awareness of them. This telescope was intended to help us in understanding how worlds shaped, so it's not shocking that it's stirring up how we decipher the universe. Previously, researchers said that the theory of how things came to be was the best clarification for how the universe started. As per this hypothesis, around 13.7 quite a while back, the universe showed up through a bewildering cosmic occasion, similar as the emotional story of the universe's introduction to the world. Nonetheless, the photographs from the James Webb Space Telescope have tested this thought. These pictures show cosmic systems that are more modest, smoother, more seasoned, and more different than what the hypothesis predicts. As indicated by the hypothesis, as the universe extends, systems ought to look greater the farther away they are. In any case, these discoveries don't keep that guideline. The hypothesis likewise expresses that toward the beginning of the universe, every one of the matter that makes up the universe was pressed into a little, super thick point called a peculiarity. This peculiarity was brilliantly hot, more sweltering than whatever we might gauge or make. This idea of a peculiarity comes from a bunch of conditions in physical science proposed by Albert Einstein called general relativity. Inside the peculiarity, all the matter in the universe was compacted into a minuscule space with high thickness. Importance, there was a gigantic measure of mass and energy stuffed into a little volume. In easier terms, researchers have reliably said that the speculation of the universe's starting point was the manner in which the universe began. In any case, right now, these new pictures from the James Webb Space Telescope are making us question that thought. The systems it found don't fit with what the hypothesis expected, and the speculative clarification of the early universe may not be pretty much as sure as we once suspected. In our ongoing comprehension of the universe, we accept that all the energy in the universe started from a very hot and thick point called a peculiarity. This peculiarity fills in as the beginning stage for all that we track down in the universe today. After this peculiarity, the universe started to extend and advance over around 13.7 billion years to become what it is today. The development began with something many allude to as inestimable expansion, where the universe developed remarkably quickly, quicker than the speed of light. It's like the actual texture of room itself was growing, and everything inside it was extending close by it. This cosmic development helped shape the universe by making things more uniform and preparing for worlds, stars, and other huge designs to frame. As the universe kept on developing, it didn't extend as fast as during expansion, yet it actually kept on getting greater. We call this constant development enormous extension. Researchers have seen evidence of this extension through things like the manner in which light from far-off worlds changes tone, known as redshift. Presently, we ought to inspect those astonishing pictures of new cosmic systems taken by the James Webb Space Telescope. To most, these photos look dazzling, with various worlds in a solitary edge. Notwithstanding, for subject matter experts, it's to some degree a shock. These photographs don't match what their hypotheses expected. In any case, these worlds are a lot more seasoned than anticipated. This difficulties how we might interpret how cosmic systems structure and develop. As indicated by the speculation of the universe's starting point, there are, to be sure, a larger number of systems than we expected. The hypothesis of the enormous detonation made expectations about the quantity of systems there ought to be and the way that they ought to be disseminated. Be that as it may, the James Webb Space Telescope pictures show a lot surprisingly universes, making researchers question whether the speculation's expectations are exact. A few researchers are in any event beginning to overreact to peace on the grounds that these revelations don't line up with their assumptions by any stretch of the imagination. One more stunning part of these new cosmic systems is their perfection, which conflicts with what the speculation of how things came to be proposes. As per the hypothesis, universes ought to show irregularities and varieties in their designs because of how they framed and developed. Notwithstanding, the photographs from the James Webb Space Telescope show systems that are especially smooth, without the standard intricacy and harshness we would anticipate. During the universe's development, all that makes up our universe was pressed into a little space. As the universe extended and cooled, changes happened, and particles like protons, neutrons, and electrons started to connect with light and energy around them. These cooperations assumed an urgent part in forming the improvement of issue in the universe. In the underlying minutes after the huge explosion, there was a cycle called nucleosynthesis, which included the development of light components like hydrogen and helium. These components set up for the improvement of stars, worlds, and more intricate components as grandiose history unfurled. The theory of the universe's origin had anticipated turbulent and upset cosmic systems because of different crashes. Nonetheless, the James Webb Space Telescope pictures recount an alternate story. Rather than savage and tumultuous cosmic systems, the photos uncover smooth plates and coordinated twisting shapes, looking like the worlds found in the cutting-edge universe. This shocking finding difficulties that crashes are a normal piece of cosmic system development. In the event that there are not many or no crashes occurring in these systems, as recommended by the speculation of the universe's starting point, it becomes improbable that little worlds could advance into a lot bigger ones. Furthermore, the optical deception anticipated by the growing universe hypothesis, where articles seem more modest with expanding distance because of extension, doesn't appear to hold. Cosmologists have seen a striking theme where worlds will quite often bunch in enormous groups, shaping complex associations across the universe. This noticed enormous scope structure lines up with the forecasts made by the theory of prehistoric cosmic detonation. As per the hypothesis, the universe started in an exceptionally hot and thick state and afterwards ceaselessly extended and cooled over the long run. As the universe extended, gravity assumed a significant part in molding how matter was disseminated and in shaping worlds. The gravitational impacts anticipated by the theory of prehistoric cosmic detonation are steady with what we see today, with gravity orchestrating matter and prompting the grouping of systems and the arrangement of interconnected filamentary structures, known as the infinite web. The presence of these world groups and the infinite web structure emphatically upholds the theory of how things came to be. How cosmic systems are dispersed across the universe lines up with the gravitational impacts anticipated from the underlying thick and extending state proposed by the speculation. These variables, including the grouping of worlds, the enormous web structure, and the circulation of cosmic system bunches, serious areas of strength forgive that the universe advanced from a very thick state and has been extending for billions of years. Presently, we ought to get back to the size of the universes found by the James Webb Space Telescope. These photographs go against what we assumed we had some awareness of the speculation of the universe's starting point. As indicated by the hypothesis, little universes ought to advance and develop through impacts and consolidations with different systems. Notwithstanding, perceptions caused by the James Webb Space Telescope to feel a piece careful about this thought. On the off chance that cosmic systems were impacting and converging true to form, we would see proof of these effects or engravings in the encompassing universes. Nonetheless, the photographs show something different. All in all, is the speculation of the huge explosion simply a hypothesis without evidence? No, it is, as a matter of fact, upheld by obvious proof, including perceptions of the redshift of light from far-off systems, which propose support for the extending universe hypothesis. Perceptions showing worlds getting away from each other toward each path recommend steady extension as anticipated by the hypothesis. The overflow of light components like hydrogen and helium found all through the universe is additionally steady with the theory of how things came to be's forecasts. Besides, the huge scope dispersion of worlds uncovered through cosmic reviews matches the examples anticipated by the hypothesis of early-stage vast explosion. One of the fundamental bits of proof for the hypothesis of early-stage grandiose explosion is the revelation of the Astronomical Microwave Foundation, CMB. The CMB is a feeble radiation that fills the whole universe and addresses the phosphorescence of the huge explosion. This radiation, first recognized in 1965, intently lines up with the forecasts made by the speculation of how things became. The noticed qualities of the CMB, including its consistency and temperature dispersion, unequivocally support the possibility that the universe was once in an unimaginably hot and thick state prior to going through development, a focal part of the speculation of the universe's starting point. The revelation of the Infinite Microwave Foundation is a basic piece of proof that gives us a striking look into the early snapshots of the universe. It fills in as a resonation of the enormous detonation. This radiation fills in as a depiction of the universe when it was only a couple 100,000 years of age, uncovering insights regarding its initial design and creation. The consistency of the CMB upholds the possibility that the universe was once in a hot, thick state and has been growing from that point onward. Moreover, the little vacillations in the CMB temperature give experiences into the thickness varieties that prompted the huge scope structure we notice today. These variances are remembered to compare to the seeds of systems and groups, offering a brief look into how matter dispersed itself in the early universe. As researchers investigate the information from the James Webb Space Telescope and other observational devices, they keep on refining how we might interpret infinite advancement. Each new disclosure can possibly reshape our models and speculations. While the theory of prehistoric cosmic detonation stays a hardy structure for making sense of the universe's beginnings, the new discoveries feature the intricacy of grandiose development and the requirement for progressing request. The fate of cosmology looks encouraging, with new advancements and techniques considering further investigation into the secrets of the universe. As we accumulate more information, we might reveal new peculiarities that challenge our ongoing models or give additional proof supporting laid-out speculations. All in all, the excursion to comprehend the universe's beginnings is progressing. The exchange between new disclosures and laid-out speculations cultivates a powerful scene of logical request. With every progression, we draw nearer to disentangling the significant secrets of our universe, and the experiences acquired will keep on moving ages of researchers and scholars.